help on.
Okay, what are we doing tonight?
Currently, like, I'm doing graphing, and then, like, for example, using PERT to find, like, salaries after being, like, using interest and stuff like that.
Okay. Can you verbalize the problem?
I'll email you it so you can see it for yourself
Okay.
if you'd like.
Sure, that works.
Okay.
Getting used to Windows 10 here. I don't think I've had a session with you since I switched over.
Yeah, I had to switch over as well.
Yeah, GoToMeeting. I had to switch from Vista, which is a major switch.
Yeah.
And I've been using Vista-like programs for 20 years. I was really familiar with that. And boy, Windows 10, I don't think I like it as much.
Oh, really?
I don't. For tutoring, it just doesn't give me quite the flexibility that I would like to have.
Yeah, that's the problem with some of these new programs, how they try to simplify things, taking away other settings.
Yeah, exactly. That's exactly what the problem is I hate the inability to size the windows, and to put more than 2 windows on the screen is tough. Like, I can do this, but if I tried to put a third one up overlapping these, I wouldn't be able to do it.
Oh, really? Okay.
Yeah, no, maybe it's just going to require me to get used to it. But so if f of x, the parent function, is 2 to the x, what is all of the things going on? Here.
Okay, so it's being vertically expanded by 5, and it's being flipped over the x-axis, and it's going down 6.
Okay, which one do you do first?
Go down 6.
All reflections.
I'll reflect first then.
Whether it's a reflection over the y-axis or the x-axis, you do that first. In other words, the way we're going to start, and it makes a difference, although it may not make a difference here. It makes a difference in some cases. So minus 2 to the x would, or 2 to the x would look like that. Minus 2 to the x would look like that. Minus 5 2 to the x would be stretched vertically, so it would look like that. And then I move this whole thing down 6. So it looks something like that.
Okay.
Now notice it does make a difference, because if I move it down 6 first, it goes down to that. And then if I flip over the x-axis, I got something that looks like that and is way away from where it's supposed to be. So and it doesn't matter if you have a vertical reflection or a horizontal reflection. As long as you do all your reflections first, you'll end up with the proper graph.
Okay. I get to use my calculator on the graphing one, so that'll help.
Yeah, I guess so. Although figuring out these transformations are not hard.
True.
Let's just go over that real quick. If you have f, some c times f of x, that's a vertical stretch or shrink, depending on whether c is greater than or equal to 1. If you have f of c times x, that is a horizontal stretch or shrink, depending on whether c is greater than or equal to 1. And these incidentally work oppositely. If this c is greater than 1, it's a stretch. If this c is greater than 1, it's a shrink. If this C is between 0 and 1, it's a shrink. But if this C is between 0 and 1, it's a horizontal stretch. So they work in opposite manners. You also have the simple one, f of x plus c. It's a vertical shift. And you have f of x plus c, where the c is inside. That's a horizontal shift. And the only other two you have is minus f of x, reflection over x. And then you have f of minus x, which is a reflection over y. And notice here, the first minus sign in that first problem is in front of the function. So I would define that as minus 5 times f of x minus 6.
Okay.
Okay? But the trick is to take the function that you're looking at and figuring out which one of these 6 it is. For example, let me give you just another. E to the x is the perfect function because it looks differently when you do everything. Okay? So what is this?
Flip over the y-axis.
And this would be flipped over the x-axis.
Correct.
And this would be
horizontal expansion.
horizontal shift.
Shift to the right two.
Right to, exactly. Shifts do not change the shape of the function. Stretches and shrinks do. Okay? So this is a shift. The function's not going to change at all. In other words, it's not going to change in appearance. There's e to the x. If I shift it, it looks exactly the same. Doesn't get stretched or shrunk. So that's the key in all of these. So here they're saying the elementary function is 1/2 to the x. So what's going on here? There's two things happening to g of x.
It is going down, no, it's going up 7, and it's being moved to the right too.
Yeah, and as long as you don't have any reflections, you can do those in either order you want. Without reflections, order doesn't matter. But with reflections, always do those first.
Okay.
Given an exponential, let me blow this up just a little bit. And move down. Okay, so number 3, in other words, f of x equal e to the x. Funny, we should be talking about that. So I'm being horizontally compressed by 3. I'm being translated 3 units to the left and 1 unit, The function has been horizontally compressed by 3, translated 3 units to the left and 1 unit to the left. I don't know what that means. Does that mean 1 unit up or down? Is this a misprint?
Possibly.
I think so, because I've never seen anything stated like this. Let's assume they meant 1 unit down.
Yeah.
What would I get?
I've never seen it like that as well.
So if we assume they meant 1 unit down, what would the g of x be?
G of x would be, so
the way I would write it would be f of 3 of x. There's the horizontal compression. So what do you end up getting? Ooh, this is kind of interesting, actually. Yeah, this is not clear exactly what it's going to be.
Yeah, with the horizontal compression.
Well, that is the compression by 3, horizontal compression by 3.
But how is it a compression if it's over 1, above 1?
Because on horizontal shrinks or stretches, a stretch is achieved by a number between 0 and 1. A shrink is achieved by a number greater than 1. For example, the best way to actually show this is with sine of x, okay? Since you've had trig. That's 2 pi, right?
Mm-hmm.
So what would y equal the sine of 2x? Is that going to be a horizontal compression or stretch?
Say that one more time, please.
Is the y equals sine of 2x going to be a stretching out horizontally or a compression horizontally?
That would be a compression.
Correct, because the number is greater than 1. And we're familiar with doing this. In other words, if we had this function, its period is pi. So I would have to draw it like that, which is, well, not quite like that. Here, let me draw it a little more correctly. It still goes up to 1, but it just has to do its thing by pi. In other words, my compressed line is exactly that. Okay. So numbers greater than 1 are compression. If that was 1/2 x, it would stretch it out to have a period of 4 pi. In other words, it would stretch it horizontally. So just remember that it works opposite of the way verticals do. In other words, if I had 2 times sine of x, that would be a vertical stretch. And if I had 1/2 times sine of x, that would be a vertical compression. So they work opposite.
Okay.
Now, the difficulty here, and we may have to plug in some points to figure it out, I'm not positive to be honest, whether the answer is this or whether the answer is that, or rather this. I think that this represents a compression by a factor of 3 and a translation by 3. And then, of course, 1 unit down would be -1.
Okay.
The question is, do you have answers on these?
No, I don't.
It'd be worth knowing the answer to this. And I'm not sure I have a way of figuring it out. Maybe we can figure it out. Let's think about this for a moment. I see another thing I don't like about this. I can't scroll down now. I can go to a new page, but I don't have any way of scrolling down. So I run out of drawing room. If this is the correct answer, first of all, the one thing we know about e to the x, all exponential functions, is they go through the point 0, 1. Okay?
Okay.
So if the compression by a factor of 3 doesn't change that point.
Okay.
In other words, a typical compression by a factor of 3 would look like that. And when x is 0, I still go through the point 1 because e to the 0 is 1. So the horizontal compression does not affect this point that it goes through. But now the translation to the right for 3 units needs to go through this point, which is going to be 3 comma 1. Okay, so if this question said compression of 3 and translated, 3 units left, that's a plus, excuse me, not a minus. Yeah, we are going to be able to figure this out. Let's just make sure I do it properly. So if I move that point 3 units left, it's at minus 3 comma 1. So if that were the only thing I was doing, would it be this or would it be that? Well, this point has to be on it. So if I use this, I get e to the 0, which is 1. If I use this, I don't get e to the 0. So this is definitely not correct. This is.
Okay.
In other words, you do your horizontal translation in parentheses, and then you do your horizontal compression or stretch in front of the parentheses. So this actually ends up being e to the 3x plus 9.
Oh.
So our correct answer on this problem is the top one, not this one here.
Okay.
And like I said, the way you can do it is use this as the key point, whether you're moving vertical or horizontal. It's that point that you want to move.
Okay.
Okay, so that was number 3. Let's look at number 4.
Okay.
Function has been reflected over the y-axis, vertically compressed by a factor of 1/3, and translated 3 units up. So what's that going to
be? So it would be e to the x, a negative x, if I'm incorrect.
That would be the reflection over the y-axis.
Yes.
Vertically compressed by a factor of 1/3.
So that would be in front of the e, 1/3.
Correct. I'm glad they didn't say horizontal, because then it gets really complicated what to do here.
So that really would be.
Yeah, it's not clear at all. We'd have to try a couple of things and see if the point ends up in the right spot. And then translated 3 units up.
Plus 3 on that side.
There's your answer. Yeah, if they'd have said horizontally, let's say instead of vertically compressed, they said horizontally translate. Oh no, they said reflected over the y-axis and horizontally translated 2 units to the right. What do you suppose that would look like? And that's it. Let's not even worry about this plus 3. So we're reflecting it over the y-axis and we're translating it 2 units to the right. So are we going to have this or are we going to have this? Which do you think?
If I'm going to the right, I believe it would be in the parentheses.
Yeah, I think you always have to put that horizontal translation in parentheses. And again, we know that e to the x is going to look like, or e to the minus x is going to look like that, going through that same point, 0, 1. And I said translated to the, I've already reflected it, So if I'm going to translate it 2 to the right, it's going to be there. And it's going to look like this because it doesn't change shape. And now that point there would be 2, 1. And does that fit that? Yeah, when x is 2, that's 0. E to the 0 is 1. Whereas if I plugged in x for 2 up there, I would have e to the minus 4, which would not be 1. So that's all you have to do is make sure you do horizontal translations in parentheses.
Okay. So this next one I can just put in the calculator.
Yeah, I'm thinking about the next one.
The main part I need help on this one is
you actually don't need to do that in your calculator. We know what 4 to the x looks like. Looks just like e to the x. It even goes, almost, even goes through that same point, 0, 1. Okay, so this is just what?
4.
No, what's the consequence of that negative sign in front of the x?
Oh, it gets reflected.
Yeah, so the reflection will look like this. And that's what it should show on your calculator.
Okay.
Let's see, was this the only page?
No, there's the lower part.
Oh,
It's stating the domain.
oh yeah, I see I still had room on my scroll bar. State the domain and the range, and they're talking about the function in 5? Oh yeah, questions 5 through 7. Okay, so looking at the blue line, what's the domain?
The domain would be negative infinity to infinity.
Yeah, do you use interval notation?
I would just use normal parentheses.
Like that?
Yes.
Okay. There's various ways to state the domain. You could also say x is all reals. Okay. But if you've been taught interval notation, that's the best, because sometimes you have multiple intervals and you put them together with a u. In other words, it would be this interval in combination with another interval, although there's no other interval that could be there when it's all real numbers. But lots of times there's, what's the range of that function looking at the graph? That's why they wanted you to graph it in your calculator.
True.
Because they want you to be able to look at the graph and figure out domain and range.
Okay, I'm graphing it right now.
Yeah, you can look at mine. You don't need to graph it on your calculator.
Okay.
What's the range of this?
The range would be, would it be 1 to...
No, look at it. The range is whatever y can be. Well, that's the y-axis.
Okay.
What's y going from? On the bottom. It's approaching this horizontal asymptote, right?
Correct.
So 0 with a parenthesis. It can never be 0. As x gets big, it gets closer and closer. What's the right upper end of the
infinity?
And pretty much all exponential, that's the range, whether they're decaying or growing. Unless, of course, you add a number to it, like that, and then it's a vertical shift, and then the range is going to be 3 to infinity.
Okay.
But there's a parenthesis because it can never be 0. There is no value of x that makes y 0. So number 7 says, describe the functions in behavior using limits. Well, what do they mean? I'm going to take the limit of what?
Of the negative x, or x going negative to the negative.
The limit of f of x as x goes to positive infinity. That's the end behavior. What is that equal to?
Infinity.
0. Look at the
Wait,
graph.
yeah, 0. Never mind. I was thinking the other way. The other one would be infinity as it goes to the negative.
So here, it's interesting. We have a horizontal asymptote at y equals 0, but the end behavior only approaches that asymptote when x goes to positive infinity. When x goes to negative infinity, it doesn't go to that asymptote. It goes to infinity. So here's a good example of where horizontal asymptotes don't necessarily apply to negative infinity and positive infinity, but in this case, just when x goes to positive infinity. So if you had limits at all, are you getting into limits now?
Yeah, more so now.
Yeah, because I have not heard you discuss limits before.
Mm-hmm.
Limits are calculus. Limits are what separates algebra, geometry, and trig from calculus. That's the one single thing that separates it. In other words, you take algebra, geometry, and trig, and you throw in limits, and you have calculus.
Okay.
Okay. Why does my...
Now my teacher taught me to do this on the calculator.
Stop sharing your screen. Why does it... Oh, if I clicked on that, I would stop sharing. You can see everything, can't you?
Yes.
Okay. Let me scroll up just a little bit because it's covering that up. Okay.
My teacher taught me to do this on my calculator.
I'm sorry, what?
My teacher taught me how to do this on my calculator.
Well, it is a calculator problem, but you need to set it up.
No, but you were saying that I could use like an apps button and plug it in and it would do it for me.
Really? Because there's 3 functions that involve exponential growth. One is annually compounded, the other is more than annually, like semi-annually, and the other is continuously. And there's a different function for each one. In one function, let's just go over it real quick. You have the starting amount times 1 plus r to the t, that's annual. Okay. More than annual is the starting amount times 1 plus r over the number of times per year it's compounded. So semi-annual, k would be 2. And then you have continuous, which is A1 ERT. Yeah, it's PERT. It's the starting principal. Instead of A lot of books will use P as your starting principal. In other words, if you can get a bank that will compound your investment continuously, this is the one you use. So this first one, we're going to use that.
Okay.
How would that look? A would be equal to what? Fill in everything.
So A would equal, so then for P.
Well, no, what's A1, first of all? A sub 1.
Say again?
What is A sub 1? That's your starting amount. That's 1,000. The total of 1,000 is invested. R is 0.07, So this becomes 1.07, and then 2 years is t. So what you want to put into your calculator is 1,000 times 1.07 squared. And that will give you what your investment will be worth at the end of 2 years. Only I used the wrong one. I didn't read the last part. Compounded continuously, we want to use this one right here.
Okay.
Apologize, I didn't read the right problem. I didn't fully read it. So it's PERT. So P is the principal. E, R is 1.07 times 2. Well, I'm trying to figure out if that's right. Is it 0.07 times 2 or is it 1.07 times 2?
The percentage?
Put that into your calculator for a moment, and I can tell you whether that should be a 0.07 or a 1.07. What is e to the 2.14 power?
To the 2.14?
Mm-hmm.
That is 8.50.
Yeah, there's no way your investment is growing to $8,500 in 2 years at 7% per year. We wish, which means I got it wrong. It's not one, it's R is the 0.07.
Okay.
So take e to the 0.14. What do you get?
Say again?
What is this number right here? E to the 0.14 power.
Okay. 0.14. 1.15.
So that's what my investment would be worth after 2 years, and that makes a lot more sense.
Okay.
So this is the correct formula, the one I have circled. The difference is the R is 0.07. It's not 1.07. Whereas up here, it's 1 plus R. So if it was compounded annually, it would be 1 plus 0.07 squared. But continuously, it's just the rate, not the rate plus 1. Okay, the second problem is compounded semi-annually. Well, which one are we going to use for that? The middle one, the bottom one? Like I said, there's 3. Got 1, 2, 3.
Okay, I'm putting it in.
It's the middle one. So when you say plugging it in, do you have like an app for this that tells you what this is, and you just plug in R and
Yes.
You do? You have, what kind of calculator do you have?
A TI-84. There's a button called apps and then finance. And then,
okay. Well, the way I would do it would be this way. So I think it's important to do it this way so that you understand it, as opposed to just blindly putting into a calculator. Watch what happens here. Let's do it manually, just for the sake of argument. 1 plus, the rate is 0.03, but it's being compounded semi-annually, which is twice a year, so K is 2. And find the balance after 7 years. Well, that's 2 times 7, so the exponent is 14. So now you could put that into your calculator and certainly come up with the answer.
Okay, I'm putting it in.
Well, you might want to simplify this. In other words, 0.03 divided by 2 is 0.015. So that thing in the parentheses becomes 1.015, like that, to the 14th power. So the first thing you'd want to put in your calculator would be 1.015 to the 14th power, and then whatever that number is, multiply by 350.
Okay.
Does your calculator give you an easier way than this to do it?
If I use the app, it does all that for me.
Does the app tell you, in other words, you must have 3 apps? One for annual compounding, one for more than annual compounding, and one for continuous compounding.
No, it does it all together. I just have to put in the separate number. Like, for example, if it's weekly, I'd put in 52 as the number. If it's daily, I'd put 365.
And if it's yearly, you put in 1. Okay.
Yes.
So you don't really use this one. You always use that one, unless it's continuous, and then you use this one.
Yes. I can't use the app if it's continuous.
Ah, okay. So the app only basically applies to that second one there.
Yeah, everything except continuous.
All right.
Well, thank you.
You're welcome, Taylor. And again, I apologize for being late, but it doesn't happen very often. I'll try to make sure it doesn't happen again.
Okay, no problem. Have a good night.
Okay, you too. Bye.